When man first looked to the skies, he was confronted by an ever-changing atmosphere that defied his understanding. To explain the weather, he did the best he could with what he had. He used his imagination. To the ancient Greeks, weather changed at the whim of the gods. Thunder and lightning were the weapons of Zeus, the most powerful god of all. Rain and snow, good weather and bad, were rewards or punishments sent from the heavens to the mortals below. But as early as the 4th century BC, Aristotle, in his treatise Meteorologica, observed that everything that is warm tends naturally to rise, a principle that we recognize today as fundamental to our understanding of the weather. Other observations form the foundation for weather proverbs. These were man's first attempts to predict the weather, and a surprising number of them have proved to be correct. Red sky at morning, a sailor's warning. When birds fly low, the storm winds blow. The weather knowledge of the ancients, a curious blend of fact and fantasy, prevailed until the 17th century. Then, with the invention of the thermometer by Galileo and the introduction of the barometer by Torricelli, the properties of the atmosphere became measurable quantities. And meteorology, the study of the atmosphere, became a science. Not every investigator brought the necessary qualities of logic and reason to the task. Some experiments were long on imagination and short on intelligence. But with the progress in the physical sciences that characterized the 17th and 18th centuries, man's understanding of the atmosphere and weather increased steadily. The mid-1800s brought the introduction of the telegraph, and the 1900s witnessed the development of radio communications. These advances made possible a network of weather stations, each reporting to others on atmospheric conditions in the area. Worldwide weather watching became a reality. Meteorological information could now be charted on maps, and for the first time, scientists were able to visualize the global patterns of atmospheric circulation. Then, with World War II, there began a wave of technological developments that have made modern meteorology one of the most complex and far-reaching of all the physical sciences. Today, meteorologists are becoming increasingly accurate in answering a question that has challenged man for centuries. What will the weather be like tomorrow? The study of weather and weather forecasting is one subject that almost everyone is interested in.
The weatherman said it was supposed to be nice today. I sure hope he's right.
50% chance of rain today. Does that mean I wear 50% of my raincoat?
Most of us are concerned about the weather because it affects our individual convenience and comfort. But weather forecasting is important in ways that influence more than our plans for work or play. With accurate weather predictions, a ship's captain can prepare for violent storms at sea. The orange grower can take steps to protect his crop against damaging frost. The rancher can protect his valuable livestock by providing food during a blizzard. Communities can plan to mobilize snow removal equipment to keep traffic flowing. Airline pilots use special weather forecasts to avoid upper air turbulence and plan their flights along the safest and most comfortable routes. All areas of the country depend on accurate weather prediction as a first line of defense against violent storms, like hurricanes and tornadoes.
We've issued a tornado warning that will
The
be
work of weather forecasting is a cooperative effort shared by many different people. Paul Swope is a meteorologist with the National Weather Service.
Hi, Gene.
Morning, Paul.
What's the weather like?
We may have some stormy weather late today.
His job is a link in our global network of weather forecasting.
Weather forecasting is an around-the-clock activity. When I arrive at the office in the morning, I'm continuing the work of other forecasters who have been on the job throughout the night. The most valuable tools we have for predicting weather are maps and charts, which show various atmospheric conditions in visual form. One of the first things I do is compare these charts with those of the previous 24 hours to get an idea of how weather patterns have changed during that time. On this chart, we've noticed a pressure system that's moving toward us. This is known as a low pressure area, or simply a low, because air pressure is lowest at the center. In North America, low pressure systems generally move from west to east. As they move, they draw in warm and cold air. Where the warm and cold air meet, fronts are produced. We have a good idea of what kind of weather will be caused by a low in its front, usually stormy, unsettled weather. Much of my time today will be devoted to predicting how this frontal system will move and when it'll reach this area. My weather charts indicate that the cold front is moving eastward through Oklahoma. We also have a large amount of moisture in the area. In a few hours, I'll prepare my forecast. It will probably indicate a dangerous weather situation. The charts and maps that I use are compiled from observations made at weather stations around the world. We even make observations at sea. Measurements are recorded and relayed to shore by radio. At many locations, instruments measure temperature, pressure, and humidity. A rain gauge records the amount of precipitation. Wind direction and wind speed are measured by a wind vane and anemometer. Conditions of the atmosphere are constantly changing. Most of the instruments we use measure these changes and record them continuously as they occur. Weather scientists use special photographic techniques to study cloud movements and weather systems. The apparent speed of movement of these clouds is caused by special photography. Overall, we rely on measurements taken at thousands of observation stations in the United States and throughout the world. To supplement the measurements made at the surface of the Earth, balloons carry miniaturized weather stations into the upper atmosphere. They gather weather information and relay it to data collecting stations on the ground by radio. Conditions in the upper air are helpful in predicting weather patterns at the surface. In addition, photographs transmitted from satellites reveal patterns of cloud motion on a day-to-day basis. This sequence of photos shows the northeastward movement of the low-pressure system that is advancing toward this weather station. All of this information, the output of thousands of weather observers, is channeled to the National Meteorological Center in Washington, D.C. Here it is reviewed and processed by high-speed computers, which automatically plot a variety of maps and charts. Specially programmed computers can also analyze the data and actually forecast atmospheric patterns. Of course, the computers can't do everything. As good as these maps and forecasts are, some must be interpreted and adjusted by experienced meteorologists. From the National Meteorological Center, completed maps and general forecasts are transmitted to local offices like ours by modern telecommunications systems. We receive the computer output in many different forms. Contour maps that show the development of weather systems at various levels in the atmosphere. Surface maps which detail the numerous observations made at each reporting station. Increasingly, we are using computer facilities that provide, at the touch of a keyboard, an instant readout of varying atmospheric conditions for any specified area, or the whole country. Although the information from Washington provides a good overall view of the weather, the detailed forecast for our region must be made in this office. Here is the low pressure system I'm concerned about today. Since early morning, the cold front of this low has been moving northeastward toward us. Satellite photographs reveal the cloud patterns associated with the low. At the time this photograph was made, the system was over eastern Kansas. We can check the weather associated with this system by looking at weather information coming into our office. As I suspected, eastern Kansas has been experiencing windy, rainy weather. With that information, I'm about ready to prepare my forecast for this area. Based upon this morning's barotropic forecast, I'm going to anticipate that this low center in Kansas will move northeastward into southeastern Wisconsin, and the cold front will advance to about the eastern border of Illinois by 1800 hours this evening. Based upon these motions, then, we're going to forecast extensive showers and thunderstorm activity over Illinois, with the possibility of some heavy thunderstorms and the danger of severe activity during the afternoon.
Paul, how far do you extend the shower activity out ahead of this system?
Well, I'm advancing the cold front at about 35 knots toward the northeast, so it would be approaching Quincy and St. Louis by noontime.
That's pretty close to what I was thinking.
Then we'll go ahead and use these for our afternoon and evening forecasts. The forecast that I prepare is sent to all the newspapers, television, and radio stations in the area. Most people are not aware of the vast around-the-clock team effort that goes into preparing a weather report. Within a few hours, almost everyone in the area will know whether our office has done a good job today.
Cue the weather.
Looking at the weather map today, we see that a high-pressure system dominates the eastern third of the nation, as well as the far west and portions of the northern plains. Our weather map also indicates that a major spring storm has developed in the Rockies and is now moving into the central plains. The intensity of this spring storm has prompted the National Weather Service Severe Storms Forecast Center to alert sections east of the plains to the possibility of severe weather today.
Just as we predicted, the storm system reached us late in the afternoon. Large weather systems, like this one, can bring varying weather conditions to different areas. Forecast offices to the north were able to predict that the same weather system would bring heavy snowfall to their areas. Farther east, forecasters tracking the storm by radar issued tornado warnings. Within hours, devastating tornadoes did strike several communities. The weather warnings to these communities probably helped save many lives. Unfortunately, we're not always that accurate in making our predictions. A small localized thunderstorm can develop within minutes. Even though it may be detected by instruments, it often occurs too rapidly to be analyzed and forecast. This is one reason why it is doubtful that we'll ever be able to forecast the weather with 100% accuracy.
Today, meteorologists continue in their search to understand the weather, investigating ways in which our weather is influenced by tropical oceans, by pollutants in the atmosphere, and by natural phenomena, such as volcanoes. Scientists are also looking at ways in which the upper atmosphere may play a role in violent storms. With our present knowledge, we can predict certain kinds of weather changes over periods of a day or two with reasonable accuracy. And we may look forward to a time when computers will be able to predict the motion of large weather systems a week or two in advance. Although our knowledge of weather has greatly advanced since ancient times, there is still much to be learned.